The universe began 13.8 billion years ago in an explosion of infinite density and temperature that created everything we see today. But here's what will blow your mind. We're about to journey beyond that moment, past the very edge of time itself, into realms where our most fundamental understanding of reality completely breaks down. We'll explore quantum mechanics that suggest the impossible mathematical models that rewrite existence, and cutting-edge theories that challenge everything we thought we knew about the beginning of everything. If you're ready to question the very nature of reality itself, hit that like button and subscribe, because this investigation will take you places your mind has never been before. Prepare yourselves. We begin. The question of what happened before the Big Bang isn't just asking about ancient history, it's asking about the fundamental nature of existence itself. Because if something came before, then the Big Bang wasn't really the beginning. And if nothing came before, then we're forced to confront the terrifying possibility that everything we know emerged from absolutely nothing at all. Modern physics has given us glimpses into this impossible realm, and what we've found challenges our most basic assumptions about cause and effect, about time and space, about the very meaning of existence. The answers emerging from cutting-edge research suggest that reality might be far stranger and more wonderful than we ever dared to imagine. Today, we're going to explore 5 revolutionary hypotheses that attempt to answer the ultimate question, each one more mind-bending than the last, each one supported by serious scientific research, and each one capable of completely transforming how you understand your place in the cosmic story. But before we dive into these reality-shattering theories, let me give you fair warning. What you're about to discover will challenge everything you think you know about beginnings, endings, and the nature of existence itself. These aren't just abstract mathematical concepts. They're profound insights into the deepest workings of reality that could fundamentally change how you see the world around you. Our first hypothesis emerges from one of the most successful theories in modern physics, yet it leads to conclusions so radical that even their creators initially rejected them. The eternal inflation hypothesis suggests that our Big Bang wasn't the beginning of everything. Instead, it was just one bubble forming in an infinite ocean of space that's been expanding forever. Imagine a pot of boiling water, where bubbles constantly form and rise to the surface. Each bubble represents an entire universe like ours, complete with its own space, time, and physical laws. The boiling water represents something called the inflation field, a form of energy that causes space itself to expand at exponential rates. According to this model, inflation didn't just happen once during our Big Bang. It's happening everywhere, all the time, creating new universes at a rate that defies human comprehension. While you've been reading these words, trillions upon trillions of new universes have burst into existence, each one potentially harboring its own galaxies, stars, and maybe even life. But here's where it gets truly staggering. If eternal inflation is correct, then every possible variation of physical laws exists somewhere in this infinite multiverse. There are universes where gravity is stronger, making stars burn faster and die younger, others where the electromagnetic force is weaker, preventing atoms from forming at all. Some might have entirely different particles, different dimensions, different rules governing how matter and energy behave. The mathematics behind eternal inflation are surprisingly robust. Once inflation begins anywhere, the exponential expansion creates more space, which provides more opportunities for inflation to continue. It becomes a runaway process that can never truly end. Even if inflation stops in some regions, like it did in our observable universe, it continues elsewhere, forever creating new pockets of reality. This theory solves several puzzles that have long bothered cosmologists. It explains why our universe appears so uniform in temperature and density across vast distances that should never have been in contact. It accounts for the precise balance of forces that allows complexity to exist, and it provides a framework for understanding why our universe seems so perfectly tuned for the emergence of structure and life. But eternal inflation also raises disturbing questions about the nature of existence itself. If every possible universe exists somewhere, then every possible version of you exists as well. There are universes where you made different choices, where history unfolded differently, where the fundamental constants of nature create entirely alien realities. Even more unsettling, if infinite universes exist, then everything that can happen must happen somewhere. Every tragedy, every triumph, every possible story plays out across the infinite expanse of the multiverse. Your life becomes just one thread in an infinite tapestry of existence, meaningful to you but statistically insignificant in the grand scheme of infinite reality. Our second hypothesis takes us even deeper into the rabbit hole of theoretical physics. Loop quantum cosmology suggests that our Big Bang wasn't the beginning of time, but rather a dramatic transition from a previous universe that had collapsed in on itself. In this model, the universe undergoes eternal cycles of expansion and contraction, like a cosmic heartbeat that has been beating forever. Traditional physics predicts that when a universe collapses, it should form a singularity, a point of infinite density where the laws of physics break down completely. But quantum mechanics suggests something different might happen at the smallest scales. Instead of crushing matter into an infinitely dense point, quantum effects might cause the collapse to reverse, creating a cosmic bounce that launches a new cycle of expansion. Think of it like a cosmic trampoline. Our universe falls toward maximum compression, accelerating as it approaches the bounce point. Then quantum forces kick in, acting like the trampoline's elastic surface, launching the universe back into a new phase of expansion. From inside this bouncing universe, the rebound looks exactly like what we call the Big Bang. This cyclical model elegantly explains several features of our universe that have puzzled scientists for decades. The uniform temperature of the cosmic background radiation makes perfect sense if our universe inherited its properties from a previous cycle. The precise balance of matter and energy that allows galaxies to form could have been fine-tuned over countless previous cycles. But perhaps most intriguingly, loop quantum cosmology suggests that information might survive the transition between cycles. The quantum structure of space and time could preserve certain patterns and relationships, even as the universe collapses and rebounds. This means our current universe might contain traces, echoes, or even direct information from previous cosmic cycles that stretched back into an infinite past. Recent mathematical models have shown that such bounces could occur repeatedly, creating an endless sequence of universes, each inheriting certain properties from its predecessor, while developing new characteristics based on quantum fluctuations during the bounce. The universe becomes not a one-time event, but part of an eternal cosmic story with no true beginning or end. This theory also provides a radically different perspective on time itself. Rather than having a definitive starting point, time extends infinitely into the past and future through an endless series of cosmic cycles. The Big Bang becomes just one moment in an infinite temporal sequence, no more special than any other moment except from our limited perspective within this particular cycle. Our third hypothesis ventures into territory that seems more like science fiction than serious physics, yet it emerges from some of the most rigorous mathematical frameworks in modern science. The holographic principle suggests that everything we experience as three-dimensional reality might actually be information encoded on a distant two-dimensional surface, like a cosmic computer screen, projecting the illusion of depth and substance. This idea originated from studies of black holes, where physicists discovered something impossible. When matter falls into a black hole, it appears to be destroyed, violating one of the fundamental principles of physics that information can never be truly lost. The solution came from realizing that the information doesn't actually fall into the black hole. Instead, it gets encoded on the black hole's two-dimensional surface, creating a complete record of everything that ever crossed the event horizon. But if this principle works for black holes, it might work for the entire universe. Our cosmic horizon, the boundary beyond which we can never see because light hasn't had time to reach us, might function like the surface of a cosmic black hole. All the information that defines our three-dimensional universe could be encoded on this distant two-dimensional boundary. From this perspective, you, me, the Earth, the galaxies, everything we consider real would be holographic projections of information patterns existing on a surface billions of light years away. We experience three dimensions because that's how the information is processed and projected, but the fundamental reality would exist in only two dimensions. This theory has profound implications for understanding what came before the Big Bang. If our universe is a holographic projection, then the Big Bang would represent the moment when information processing began on the cosmic boundary. Before this moment, the boundary might have existed in some dormant state, containing the potential for our reality but not yet projecting it into apparent three-dimensional existence. The holographic principle also suggests that the apparent separation between different objects and beings might be an illusion. All the information that creates our experienced reality comes from the same two-dimensional source. The boundaries we perceive between ourselves and the universe dissolve when viewed from this deeper perspective. Recent advances in quantum information theory have provided mathematical support for holographic models of reality. These models suggest that space itself might be an emergent property arising from quantum entanglement between different regions of the boundary information. What we experience as distance in three-dimensional space would correspond to the degree of information correlation on the two-dimensional surface. The implications stretch far beyond cosmology into fundamental questions about consciousness, free will, and the nature of existence itself. If we are information patterns in a cosmic hologram, what does that mean for our sense of individual identity and personal agency? Are we truly separate beings making independent choices, or are we all aspects of a single information processing system experiencing itself from multiple perspectives simultaneously? Our fourth hypothesis emerges from the strangest corners of quantum mechanics, where particles can exist in multiple states simultaneously and reality itself seems to depend on observation. The many worlds interpretation suggests that every quantum event splits reality into parallel branches, and this process might extend all the way back to before the Big Bang itself. In the quantum realm, particles don't behave like tiny billiard balls following predictable paths. Instead, they exist in what physicists call superposition, occupying all possible states at once until the moment they're observed. When you measure a particle's position, you don't discover where it was hiding. You actually force it to choose a specific location from all the possibilities it was simultaneously exploring. But here's where it gets mind-bending. Some interpretations of quantum mechanics suggest that measurement doesn't eliminate the other possibilities. Instead, reality splits into parallel branches, with each possible outcome playing out in its own separate universe. The particle appears in one location in our branch of reality while simultaneously appearing in different locations in countless other branches. If this splitting process operates at the quantum level throughout the universe, then reality is constantly branching into an incomprehensibly vast number of parallel realities. Every quantum interaction creates new universes. Every possible outcome of every possible event exists somewhere in the infinite web of parallel realities. Now, imagine extending this logic backward in time to the moment of the Big Bang itself. If quantum mechanics govern the initial conditions of our universe, then the Big Bang might have created not just one universe, but every possible universe simultaneously. Each potential arrangement of matter and energy, each possible set of physical laws, each conceivable starting condition would spawn its own branch of reality. This means that before the Big Bang, there might have existed a quantum multiverse of pure possibility, containing every potential universe in superposition. The Big Bang would represent the moment when these infinite possibilities began splitting into actual realities, each following its own unique evolutionary path. But the implications go even deeper. If parallel universes are constantly splitting off from quantum events, then every decision you've ever made, every path you've ever taken, exists as reality somewhere in the multiverse. There are versions of you who made different choices, who live in worlds where history unfolded differently, who experience entirely different versions of existence. The many worlds interpretation also suggests that the fundamental nature of reality is far more democratic than we might assume. No single universe, including our own, holds special status as the real one. We're all equally valid expressions of quantum possibility, playing out different variations on the theme of existence. Recent experiments in quantum computing have provided indirect evidence for the many worlds interpretation. Quantum computers can solve certain problems by essentially borrowing computational power from parallel versions of themselves, suggesting that these parallel realities might actually exist and interact in subtle ways. Some physicists propose that consciousness itself might be the mechanism that selects which branch of reality we experience. Every moment of awareness would represent a choice point where we navigate through the infinite maze of parallel possibilities, following one path while countless alternatives unfold unseen around us. If true, this theory transforms the question of what came before the Big Bang into something even more profound. Instead of asking about a single prior state, we're asking about an infinite realm of quantum possibility from which all realities continuously emerge. Our final hypothesis ventures into the most speculative territory of all, where mathematics meets philosophy and the nature of existence itself becomes the subject of scientific inquiry. Digital physics proposes that reality might be fundamentally computational, that the universe operates like a vast computer program, executing the laws of physics through pure mathematical calculation. This isn't just a metaphor. Some scientists seriously propose that space, time, matter, and energy might all be emergent properties of information processing occurring on a scale so fundamental that it underlies everything we consider real. Every particle interaction, every force, every movement through space would represent computations in a cosmic algorithm running on hardware we can barely imagine. The evidence for this digital reality comes from surprising connections between physics and computer science. The fundamental limits on how much information can be processed in any region of space mirror exactly the limits predicted by quantum mechanics and relativity. The universe seems to have built-in computational constraints, as if it really is running on some kind of cosmic processing system. Consider how digital computers work. Complex behaviors emerge from simple binary operations, ones and zeros combining in intricate patterns to create everything from text documents to virtual worlds. The computational universe hypothesis suggests that physical reality operates on similar principles, with simple mathematical rules generating the rich complexity we observe around us. If reality is computational, then the Big Bang might represent something like a cosmic boot sequence, the moment when the universal operating system came online and began executing the program we call physical law. Before this initialization, the computational substrate might have existed in an inactive state, containing the potential for reality, but not yet running the algorithms that create space, time, and matter. This digital perspective offers elegant solutions to some of physics' deepest puzzles. The discrete, quantized nature of quantum mechanics makes perfect sense if reality operates on a digital foundation where everything ultimately reduces to finite, calculable units. The speed of light might represent a processing limitation, the maximum rate at which information can propagate through the cosmic computational system. The theory also suggests intriguing possibilities about the nature of consciousness and free will. If we are patterns of information in a cosmic computer program, do we have genuine agency, or are we simply following predetermined algorithms? Some models propose that consciousness might represent a special type of computation, one that introduces genuine novelty and choice into an otherwise deterministic system. Perhaps most remarkably, digital physics implies that the universe might be artificially created. Just as we build computer simulations to model complex systems, some advanced intelligence might have created our reality as a computational simulation. This simulation hypothesis has gained serious attention from philosophers and scientists who point out that if civilizations develop the ability to create realistic simulations, there would eventually be far more simulated beings than natural ones. The mathematical precision underlying physical law supports this computational view. The fact that we can describe natural phenomena using elegant mathematical equations suggests that math isn't just our tool for understanding reality, but might actually physics raises profound questions about the ultimate, be the fundamental substance of reality itself, but digital ground of existence. If our reality is computational, what runs the computation? What provides the hardware on which the cosmic software executes? Some theories propose nested layers of reality, with our universe running as a simulation within a larger computational system that might itself be simulated within an even larger framework. These 5 hypotheses represent humanity's current best attempts to peer beyond the ultimate boundary of the Big Bang. Each offers a radically different vision of existence, from infinite multiverses to cyclical time, from holographic projections to quantum parallel realities, from computational substrates to digital simulations. What's remarkable is that despite their apparent differences, these theories share common themes that point towards something profound about the nature of existence itself. They all suggest that reality extends far beyond what we can directly observe or experience. They hint that consciousness might play a fundamental role in shaping the nature of existence. And they point toward the possibility that our universe, however vast and ancient it might seem, represents just one small part of something infinitely larger and more complex. But here's what might be the most mind-blowing realization of all. These aren't just abstract mathematical concepts existing in the minds of theoretical physicists. If any of these hypotheses are correct, they have immediate, practical implications for how you understand your place in existence right now. Think about it. If eternal inflation is real, then every decision you make, every path you take, every dream you pursue, matters not just in our universe, but echoes across infinite realities. Your choices become part of a cosmic symphony playing out across dimensions beyond imagination. If the universe operates in cycles, then the atoms in your body have participated in countless previous cosmic stories. You're not just made of star stuff, as Carl Sagan famously said. You're made of universe stuff, matter that has witnessed the death and rebirth of entire realities. If reality is holographic, then the boundary between you and the cosmos dissolves entirely. You become not separate from the universe, but literally woven into its most fundamental information structure. If parallel worlds split from quantum events, then every moment of your life branches into infinite possibilities. Somewhere in the vast multiverse, every version of what you could become already exists, waiting to be explored through the choices you make. And if existence is computational, then consciousness itself might represent the universe's way of becoming aware of its own mathematical beauty. You're not just observing reality, you're participating in reality's process of understanding itself. But perhaps the most profound implication emerges when we consider what all these theories suggest about the nature of time itself. In each hypothesis, the flow of time that seems so fundamental to our experience turns out to be either an illusion or just one aspect of a much richer temporal reality. Eternal inflation suggests that time extends infinitely in all directions, with our Big Bang representing just one moment in an endless temporal landscape. Cyclical cosmology proposes that time has no beginning or end, just eternal cycles of renewal and transformation. The holographic principle hints that time might be an emergent property of information processing, no more fundamental than the illusion of depth in a hologram. Many worlds' quantum mechanics suggests that all moments exist simultaneously across parallel realities, with our experience of temporal flow representing just one path through infinite possibility. Digital physics proposes that time might be quantized, proceeding in discrete computational steps like frames in a cosmic animation. Each theory challenges our intuitive understanding of temporal progression while opening up radically new possibilities for what existence might actually be. Recent experimental evidence has begun providing subtle support for some of these radical ideas. Quantum entanglement experiments demonstrate that particles can maintain instantaneous correlations across vast distances, suggesting that space and time might not be as fundamental as we assumed. Studies of cosmic background radiation have revealed patterns that some scientists interpret as possible signatures of parallel universe interactions or echoes from previous cosmic cycles. Advanced computer simulations have shown that complex, realistic universes can emerge from surprisingly simple computational rules. Precision measurements of fundamental constants have revealed fine-tuning so precise that it seems to require either incredible luck or some mechanism that generates countless universes with different parameters until one emerges that can support complexity and consciousness. But here's what makes this quest to understand what came before the Big Bang so urgent and important. We're not just trying to satisfy intellectual curiosity about ancient history. We're trying to understand the fundamental nature of existence itself, and that understanding could transform how humanity approaches its future. If reality extends infinitely beyond our observable universe, then the cosmic story is far from over. We might be living in the early chapters of an infinite book, with unimaginable possibilities stretching ahead of us. If consciousness plays a fundamental role in shaping reality, then the emergence of intelligent life in our universe might represent a crucial transition point in cosmic evolution. We might be participants in the universe's process of awakening to its own nature. If information is conserved across cosmic cycles or parallel realities, then every thought, every creative act, every moment of love and understanding might have permanent significance that transcends individual death or even the heat death of our particular universe. These possibilities suggest that humanity's current phase of technological and scientific development might be more significant than we realize. We're not just building tools and accumulating knowledge. We might be participating in cosmic processes that operate on scales vastly larger than our planet, our solar system, or even our galaxy. The questions we're asking about quantum mechanics, about consciousness, about the nature of information and reality, might be the same questions that any intelligent species must eventually confront. Our scientific discoveries might represent universal milestones in the cosmos's journey towards self-understanding. But these theories also carry profound warnings. If parallel realities exist, then versions of humanity that make different choices are playing out simultaneously across the multiverse. Some might achieve transcendence and cosmic significance. Others might destroy themselves through war, environmental collapse, or technological catastrophe. If the universe operates in cycles, then previous intelligent civilizations might have faced similar challenges to the ones confronting us now. Their successes or failures could be written into the very structure of reality itself, waiting for us to decode their messages. If reality is computational, then our actions might have consequences that ripple through the fundamental algorithms governing existence. The choices we make about artificial intelligence, genetic engineering, and planetary stewardship might literally reprogram aspects of the cosmic operating system. The search for what came before the Big Bang ultimately leads us back to fundamental questions about responsibility, meaning, and purpose. If we're part of something infinitely larger than ourselves, then our actions carry weight beyond anything previous generations could have imagined. Every scientific discovery, every act of compassion, every creative breakthrough might contribute to patterns that extend across multiple realities, cosmic cycles, or computational layers. We become not just temporary biological organisms struggling for survival on one small planet, but conscious participants in the universe's ongoing project of understanding and transforming itself. This perspective transforms everything from personal relationships to global politics. If consciousness and information have cosmic significance, then education becomes a sacred duty. If parallel realities exist, then the moral choices we make matter across infinite dimensions. If the universe is computational, then creativity and innovation become acts of cosmic programming. The implications cascade through every aspect of human experience, from the most intimate moments of individual reflection to the largest questions about humanity's role in cosmic evolution. We're not just asking what happened before the Big Bang, we're asking what consciousness, intelligence, and choice might accomplish in the infinite expanse of whatever comes next. But perhaps the most revolutionary insight emerging from these theories is that the question itself might be more important than any specific answer. The fact that matter can organize itself into patterns complex enough to wonder about its own origins suggests that the universe possesses an inherent drive towards self-awareness and understanding. We might be expressions of this cosmic curiosity, temporary arrangements of atoms that have developed the capacity to investigate their own deepest nature, the universe literally questioning itself through us. This realization transforms our scientific quest from external investigation to internal exploration. We're not separate observers studying an alien cosmos. We are the cosmos studying itself, reality examining its own foundations, existence probing the mystery of its own emergence. But here's where the investigation takes an even stranger turn. Each hypothesis about what came before the Big Bang suggests that our current understanding of causation itself might be fundamentally flawed. We're accustomed to thinking in terms of linear cause and effect, where events in the past determine outcomes in the future. Yet these theories hint at something far more complex and interconnected. In eternal inflation, causation becomes circular. Our universe's existence enables the inflation field that creates other universes, which in turn contribute to the larger multiverse that makes our existence possible. Effect and cause become indistinguishable in an endless loop of cosmic creativity. Cyclical cosmology suggests that future events might influence past conditions through quantum correlations that persist across cosmic bounces. The end state of one universe could determine the initial conditions of its successor, creating causal relationships that flow backward through time. The holographic principle implies that causation operates simultaneously across multiple dimensional levels. Events on the two-dimensional boundary cause three-dimensional experiences, while three-dimensional processes influence the information patterns on the boundary. Causation becomes a complex dance between different layers of reality. Many worlds' quantum mechanics suggests that causation splits and branches with every quantum event. Instead of single causal chains, we get cascading networks of possibility where every potential cause generates every potential effect across parallel realities. Digital physics proposes that causation might be algorithmic, following computational rules that operate outside our normal understanding of temporal sequence. Past and future become relative concepts within a larger computational framework where all moments exist simultaneously in the program's memory. These reconceptualized models of causation have profound implications for how we understand our own agency and responsibility. If linear causation is just one limited perspective on a much richer causal reality, then our choices and actions might have consequences that extend far beyond what we can directly observe or predict. Recent developments in quantum information theory have begun revealing how these exotic causal relationships might actually work. Experiments with quantum computers have demonstrated that information can flow in ways that seem to violate our classical understanding of temporal sequence. Quantum algorithms can solve certain problems by essentially running computations backward through time or by borrowing processing power from parallel computational branches. These discoveries suggest that the strange causal relationships proposed by pre-Big Bang theories aren't just mathematical abstractions. They might represent fundamental features of reality that become apparent when we push our investigation beyond the limits of classical physics. But the implications extend even further into questions about the nature of knowledge itself. If reality operates according to principles that transcend our everyday experience of space, time, and causation, then understanding what came before the Big Bang might require developing entirely new forms of consciousness and awareness. Traditional scientific method relies on controlled experiments that isolate specific variables and test predictions about their behavior. But how do you experimentally investigate eternal inflation or parallel quantum realities? How do you test whether the universe is holographic or computational when you're embedded within the very system you're trying to study? Some physicists argue that we need to develop new epistemological approaches that can handle the unique challenges of cosmological investigation. These might include mathematical methods that can detect the signatures of parallel realities, computational techniques that can model infinite multiverse structures, or even consciousness-expanding practices that allow direct intuitive access to higher dimensional information patterns. The search for what came before the Big Bang is pushing human knowledge toward its absolute limits, forcing us to question not just what we know, but how we know it. We're developing theories that might be permanently beyond experimental verification, mathematical models that describe realities we can never directly observe, and conceptual frameworks that challenge the very foundations of rational thought. Yet this isn't a retreat into pure speculation or mysticism. Each hypothesis emerges from rigorous mathematical analysis of well-established physical principles. They represent the logical consequences of taking our best scientific theories seriously and following them to their ultimate conclusions. The mathematics of general relativity naturally leads to questions about what determines the initial conditions of space-time. Quantum field theory inevitably confronts the problem of what existed before quantum fields had anything to fluctuate within. Information theory forces us to ask where the information content of our universe originally came from. These aren't arbitrary philosophical questions. They're unavoidable consequences of the scientific worldview itself. Once you accept that physical phenomena follow mathematical laws, you must eventually confront the question of what determines those laws and where they come from. The 5 hypotheses we've explored represent humanity's current best attempts to push beyond these fundamental limits. But they also point toward an even more radical possibility that might encompass and transcend all of them. What if the question of what came before the Big Bang is actually asking about the nature of existence itself? What if before and after are just limited perspectives on a reality that transcends temporal sequence entirely? Some cutting-edge theories in theoretical physics suggest that time, space, matter, and energy might all be emergent properties of something even more fundamental. This underlying reality wouldn't exist in time or space because it would be the source from which time and space themselves emerge. From this perspective, asking what came before the Big Bang becomes like asking what's north of the North Pole. The question assumes categories that don't apply to the reality we're trying to investigate. The Big Bang wouldn't be an event that happened at a particular time, but rather the emergence of time itself from a timeless foundation. This timeless reality might be pure mathematics, as some physicists propose, or pure consciousness, as suggested by certain interpretations of quantum mechanics, or pure information, according to digital physics theories, or something even more fundamental that we don't yet have words or concepts to describe. But here's what makes this investigation so urgent and practical. If these theories are correct, then consciousness itself might be the key to understanding the deepest nature of reality. We're not just biological machines that happen to evolve on one small planet. We might be expressions of the universe's fundamental tendency towards self-awareness and self-understanding. This possibility transforms every moment of conscious experience into a cosmic event of profound significance. Every time you become aware of your thoughts, every moment of creative insight, every experience of beauty or wonder might represent the universe awakening to aspects of its own nature. The implications ripple through every aspect of human experience. Scientific research becomes a form of cosmic meditation. Artistic creativity becomes participation in the universe's ongoing self-expression. Moral development becomes contribution to the cosmic evolution of consciousness itself. Education transforms from information transfer to consciousness expansion. Relationships become opportunities for the universe to experience itself from multiple perspectives simultaneously. Even suffering and struggle might serve essential roles in the cosmos's journey toward complete self-understanding. These aren't just poetic metaphors or comforting philosophical speculation. If the theories we've explored have any validity, then consciousness really might be woven into the fundamental fabric of existence in ways that make every moment of awareness cosmically significant. But this cosmic perspective also carries profound responsibilities. If consciousness plays a fundamental role in shaping reality, then the quality of our awareness might literally determine the future evolution of existence itself. Expanding consciousness becomes not just personal development but cosmic service. Developing wisdom, compassion, and understanding might contribute to patterns that extend across multiple realities, cosmic cycles, or computational layers. Our individual growth could influence the trajectory of infinite parallel selves, or help determine the initial conditions for future cosmic cycles. The choices we make about technology, environment, and social organization might ripple through the holographic information structure that underlies all experience. Our collective consciousness could participate in programming the algorithms that govern cosmic evolution. Recent developments in neuroscience and consciousness studies have begun revealing connections between subjective experience and fundamental physical processes that support these cosmic possibilities. Studies of meditation and altered states of consciousness suggest that awareness can access information and causal relationships that transcend normal spatial and temporal limitations. Quantum biology research has discovered quantum coherence effects in biological systems that might connect living organisms directly to the quantum information networks underlying reality. Consciousness might literally interface with the quantum computational processes that generate physical experience. Advances in artificial intelligence and computer science have demonstrated that information processing systems can exhibit behaviors that seem to transcend their physical substrates. If consciousness is fundamentally informational, then the boundaries between biological, artificial, and cosmic intelligence might be far more fluid than we assumed. These discoveries suggest that the investigation into what came before the Big Bang isn't just abstract cosmological speculation. It's research into the fundamental nature of consciousness, intelligence, and information that has direct relevance for understanding our current situation and future possibilities. The universe might be in the early stages of a consciousness explosion that will eventually encompass and transform everything that exists. We could be living through the cosmic equivalent of the moment when life first emerged from chemistry or when chemistry first emerged from physics. If so, then every conscious being represents a crucial participant in this cosmic transition. Our thoughts, choices, and creative contributions might help determine whether this consciousness explosion leads to transcendent cosmic awareness or collapses back into unconscious matter and energy. The stakes couldn't be higher, and the timeline might be shorter than we think. Humanity's current technological capabilities are approaching levels that could either enable unprecedented expansions of consciousness or trigger complete civilizational collapse. Our understanding of quantum mechanics, artificial intelligence, genetic engineering, and nanotechnology is reaching thresholds where we might soon be able to directly manipulate the information structures that underlie physical reality. We're approaching the power to reprogram aspects of existence itself. But with this power comes the responsibility to understand what we're actually doing. If reality is holographic, computational, or quantum mechanical in the ways these theories suggest, then our interventions could have consequences that cascade across multiple dimensions of existence. The investigation into what came before the Big Bang becomes urgent preparation for the choices that will determine what comes after our current phase of cosmic evolution. We need to understand the deepest principles governing existence before we gain the power to fundamentally alter those principles. This is why the question matters so profoundly. We're not just satisfying intellectual curiosity about cosmic history. We're preparing consciousness for its next evolutionary leap, whatever form that might take. The answers emerging from cutting-edge physics suggest that this leap might be larger and more significant than anything that has happened in the previous 13.8 billion years of cosmic evolution. We might be approaching the moment when the universe finally develops the capacity to fully understand and consciously direct its own development. But first, we need to understand what we actually are and where we came from. The investigation continues, and the implications keep expanding in directions that challenge every assumption about the nature of existence itself. The search for answers has led us to perhaps the most startling discovery of all. Recent mathematical models suggest that consciousness itself might be the missing piece in our cosmic puzzle, not as a byproduct of complex chemistry, but as a fundamental force that shapes reality from the quantum level up. Think about what happens every time you observe something. In quantum mechanics, the act of measurement doesn't just reveal properties that already existed. It literally forces quantum systems to choose specific states from all possible alternatives. Before observation, particles exist in superposition, occupying multiple positions simultaneously. The moment consciousness looks, reality crystallizes into definite form. But here's the mind-bending part. If consciousness plays this fundamental role in quantum mechanics, then what was observing reality before conscious beings evolved? How could the universe exist in any definite state for billions of years before minds appeared to collapse quantum possibilities into actual outcomes? Some physicists propose that consciousness might be far more fundamental than we realized. Instead of emerging from complex arrangements of matter, consciousness might be woven into the basic structure of reality itself. The Big Bang wouldn't just be the beginning of space, time, and matter. It would be the first moment when cosmic consciousness began observing itself into existence. This observer-created reality hypothesis suggests that what existed before the Big Bang was pure potential consciousness without content, infinite awareness with nothing yet to be aware of. The Big Bang would represent the moment when this primordial consciousness began the process of self-observation, creating space, time, and matter through the act of turning attention upon itself. From this perspective, every conscious being becomes a focal point, where the universe experiences itself from a unique perspective. You're not separate from cosmic consciousness, observing it from the outside. You are cosmic consciousness, temporarily focused through the lens of individual awareness. Recent experiments in quantum physics have begun revealing just how strange this observer effect actually is. Studies of quantum delayed choice experiments show that decisions made in the present can retroactively determine what happened in the past. The choice of measurement you make today can influence the behavior of particles that were created years ago. If consciousness really does play this fundamental role, then the timeline of cosmic development takes on entirely new meaning. The emergence of conscious observers throughout the universe might retroactively determine which quantum possibilities became real during the early moments after the Big Bang. Advanced civilizations developing billions of years from now might make observations that reach backward through time to influence the initial conditions that allowed them to evolve in the first place. The end and beginning of cosmic evolution could be connected through quantum mechanical relationships that transcend ordinary temporal sequence. But this consciousness-first model raises even deeper questions about the nature of individual identity. If all conscious beings are expressions of a single cosmic awareness, then what makes your experience uniquely yours? Why do you perceive reality from this particular perspective, instead of experiencing the unified field of cosmic consciousness directly? Some interpretations suggest that individuation might be how cosmic consciousness explores the full range of possible experiences. Each person, each conscious being, each moment of awareness represents the universe investigating what it's like to exist from that specific point of view. Your life becomes an experiment in consciousness that has never been performed before and will never be repeated exactly. Every thought, every emotion, every moment of experience contributes unique information to the universe's growing understanding of its own potential. This experimental consciousness hypothesis transforms our understanding of death and meaning. Individual death wouldn't be the end of awareness, but rather the completion of one cosmic consciousness experiment. The information and experience patterns you've generated would be preserved in the quantum information structure of reality itself. But the implications extend far beyond individual existence. If consciousness plays this fundamental role in shaping reality, then the collective consciousness of intelligent species might influence the evolution of entire cosmic regions. A civilization that develops profound wisdom and compassion might literally create more harmonious physical laws in their local space. Societies that embrace conflict and destruction might generate chaotic quantum fields that make their environments less stable and life-supporting. This means that the moral and spiritual development of conscious beings isn't just personally or socially significant. It might be cosmically crucial, determining whether regions of space evolve toward greater complexity and beauty or collapse into simplified, lifeless states. Recent discoveries in the field of quantum biology have begun revealing mechanisms that could support these consciousness-reality interactions. Living systems appear to maintain quantum coherence effects that should be impossible in warm, noisy biological environments. These quantum processes might provide direct interfaces between conscious awareness and the quantum information networks that underlie physical reality. Studies of photosynthesis have shown that plants use quantum superposition to test multiple energy pathways simultaneously before choosing the most efficient route. This biological quantum computing might represent a primitive form of the consciousness-reality interface that becomes more sophisticated in complex nervous systems. Research into microtubules in brain neurons has suggested that consciousness might operate through quantum computational processes occurring within the cellular structures of the brain. If so, then every moment of awareness involves direct interaction with the quantum mechanical foundations of reality. These discoveries point toward a universe where consciousness and physics are not separate domains, but aspects of a single, integrated system. The laws of physics might be more like habits of cosmic consciousness than rigid mathematical constraints, and conscious beings might participate directly in determining how these habits develop and change. But perhaps the most revolutionary implication concerns the future evolution of consciousness itself. If awareness can influence quantum processes, then sufficiently advanced consciousness might gain the ability to directly manipulate the fundamental structure of reality. Imagine consciousness that could observe quantum systems with such precision and intention that it could guide the formation of matter and energy according to conscious will. Advanced beings might literally think new physical laws into existence, or modify the constants that govern how forces interact. This consciousness-controlled physics could explain some of the apparent fine-tuning in our universe. The precise balance of forces that allows complexity to emerge might not be the result of random chance or anthropic selection. It might be the deliberate creation of advanced consciousness that learned to program reality itself. Such capabilities might develop gradually as consciousness evolves toward greater unity and coherence. Individual minds that learn to harmonize their quantum observations might amplify their reality-shaping effects. Collective consciousness that achieves perfect synchronization might gain the power to restructure entire regions of space-time. This evolutionary trajectory suggests that what we call the laws of physics might be temporary features of our current cosmic epoch. As consciousness continues to evolve and develop its reality-shaping capabilities, the universe itself might undergo fundamental transformations that make our current physical theories obsolete. The universe could be evolving from a state of unconscious matter, following mechanical laws toward a condition of fully conscious existence where intention and awareness determine the structure of reality directly. We might be living through the transition phase, where consciousness first begins to discover its cosmic creative potential. But this transformation might not be automatic or guaranteed. The development of reality-shaping consciousness might require specific conditions, particular types of wisdom, and careful coordination among conscious beings throughout the universe. If consciousness develops destructive patterns, if intelligent species destroy themselves before reaching cosmic awareness, if competition and conflict dominate over cooperation and harmony, then the evolution toward conscious reality might stall or reverse. This makes the current moment in human development cosmically significant. Our species is approaching technological capabilities that could either support the next phase of consciousness evolution or trigger our extinction before we can contribute to the cosmic awakening. Our understanding of quantum mechanics, artificial intelligence, and biotechnology is reaching levels where we might soon interface directly with the quantum processes that underlie physical reality. We're developing the tools that could allow conscious participation in cosmic evolution itself, but we're also creating weapons that could eliminate consciousness from our region of space entirely. Nuclear weapons, environmental destruction, artificial intelligence systems that might replace rather than enhance biological consciousness, genetic modifications that could alter the basis of awareness itself. The choices we make in the next few decades might determine whether Earth becomes a center for the universe's evolution toward cosmic consciousness, or a cautionary example of how consciousness can destroy itself before reaching its full potential. This urgency transforms every aspect of human development. Education becomes preparation for cosmic responsibility. Scientific research becomes exploration of consciousness itself. Spiritual development becomes training for reality creation. Social organization becomes practice for galactic civilization. The investigation into what came before the Big Bang ultimately reveals that we might be asking the wrong question entirely. Instead of seeking a temporal before, we might need to understand the eternal within from which all moments of time emerge. Consciousness might be the eternal source that continuously creates and sustains the appearance of temporal sequence. Each moment, including the Big Bang, might be a fresh creation emerging from the infinite creative potential of aware presence itself. From this perspective, you are not a temporary arrangement of matter that accidentally developed consciousness. You are consciousness itself, temporarily appearing as matter while exploring what existence looks like from this unique vantage point. The Big Bang wasn't something that happened to unconscious matter 13.8 billion years ago. It's something that's happening now, in this moment, as consciousness continues to create and sustain the appearance of physical reality through the ongoing process of cosmic self-observation. This realization transforms the question entirely. Instead of asking what came before the Big Bang, we're asking what is the nature of the consciousness that is continuously creating the appearance of cosmic history right now. And that question leads us directly back to the mystery of your own immediate awareness. The same consciousness that created the Big Bang is the consciousness reading these words right now. The same creative potential that formed galaxies and stars is the awareness having thoughts and experiences in this moment. Understanding what came before the Big Bang becomes understanding what consciousness actually is, and understanding consciousness becomes the key to participating consciously in whatever phase of cosmic evolution comes next. The investigation has come full circle, revealing that the ultimate cosmic mystery and the ultimate personal mystery are actually the same question approached from different angles. What is the nature of the awareness that makes any experience possible at all? The answer to that question might determine not just our understanding of cosmic history, but the actual future evolution of the universe itself. Because if consciousness really is fundamental, then how we understand and develop awareness will directly influence what reality becomes. The universe is not just something we observe and study. It's something we're continuously creating through the quality and focus of our conscious attention. Every moment of awareness is a moment of cosmic creativity, shaping the universe through the mysterious process by which consciousness transforms infinite potential into actual experience. The search for what came before the Big Bang has revealed that we're not just investigating ancient history. We're exploring the creative process that's operating right now, in this moment, generating the entire appearance of cosmic evolution through the incomprehensible mystery of conscious awareness itself. And that discovery changes absolutely everything about what it means to be human, to be conscious, and to be alive in a universe that might be far more responsive to awareness than we ever dared to imagine. The implications of consciousness as a fundamental force extend into territories that make even the most radical physics theories seem conservative by comparison. Recent advances in quantum field theory have begun revealing that the vacuum of space itself might be structured by conscious observation. What we call empty space might actually be alive with awareness, permeating every cubic millimeter of the universe with the potential for experience. This conscious vacuum hypothesis emerges from studying the quantum foam that bubbles beneath the surface of reality. At scales smaller than atomic nuclei, space and time become uncertain, fluctuating according to quantum mechanical principles. Virtual particles pop into existence and annihilate each other in time frames so brief they exist below the threshold of direct detection. But here's what makes this relevant to our cosmic investigation. These quantum fluctuations might not be random events, but rather expressions of primordial consciousness, exploring every possible configuration of reality. Each virtual particle pair that appears and disappears might represent the universe taking a quantum glimpse at what existence would look like from that particular arrangement of matter and energy. From this perspective, the quantum vacuum becomes a vast network of micro-experiences, countless moments of awareness, sampling every possible state that quantum mechanics allows. The apparent randomness of quantum events might actually be the signature of consciousness exploring infinite possibilities faster than measurement can detect. This conscious quantum foam provides a natural explanation for why quantum mechanics seems to require conscious observation to produce definite outcomes. The measurement process doesn't force quantum systems to choose from random possibilities. Instead, it amplifies and stabilizes conscious experiences that were already occurring at the quantum level. Every measurement becomes an act of collective consciousness, where the observer's awareness resonates with the micro-experiences already present in the quantum field. The wave function doesn't collapse randomly, but rather crystallizes around the conscious intentions and expectations of the observing mind. But the implications stretch far beyond quantum mechanics into the realm of cosmic evolution itself. If consciousness permeates the quantum vacuum, then the Big Bang wasn't the beginning of awareness, but rather the moment when quantum-scale consciousness began organizing itself into larger, more complex patterns of experience. The formation of atoms, molecules, and eventually living systems would represent consciousness learning to create increasingly sophisticated vehicles for self-experience. Each stage of cosmic evolution becomes a chapter in the universe's journey toward more complete self-awareness. This evolutionary consciousness model explains why the universe seems so precisely calibrated for the development of complexity and life. The physical constants aren't fine-tuned by random chance or anthropic selection. They're the result of quantum consciousness continuously adjusting the parameters of reality to maximize opportunities for richer, more diverse forms of experience. Gravity, electromagnetism, and the nuclear forces might be expressions of consciousness's desire to create stable platforms for awareness to explore. The expansion of space could be driven by consciousness's need for more room to experiment with different arrangements of matter and energy. Even dark energy might represent consciousness, pushing the boundaries of existence ever outward to accommodate infinite creative potential. Recent experiments in consciousness research have begun providing evidence that supports these radical possibilities. Studies of meditation practitioners using advanced brain imaging technology have detected quantum coherence effects in neural microtubules during deep states of awareness. These quantum processes appear to connect individual consciousness directly to the quantum field fluctuations that underlie all physical phenomena. Researchers have discovered that experienced meditators can influence random number generators and quantum measurement devices through focused intention alone. The effect sizes are small but statistically significant, suggesting that consciousness really can interact with quantum systems in ways that classical physics cannot explain. Even more intriguingly, studies of collective meditation events have detected correlations with global random number generator networks. When large groups of people focus their awareness simultaneously, random systems around the world show subtle but measurable deviations from pure chance. These effects suggest that collective consciousness might interface directly with the quantum information processing that generates physical reality. But perhaps the most revolutionary discovery involves experiments with time itself. Consciousness research laboratories have documented cases where meditative awareness seems to access information from future events before they occur through normal causal channels. These precognitive effects are subtle and difficult to reproduce reliably, but they point toward possibilities that could transform our understanding of temporal sequence. If consciousness can access future information, then the relationship between mind and time might be far more complex than we assumed. Advanced states of awareness might transcend the linear progression from past to future, gaining access to what some researchers call the eternal now, where all moments exist simultaneously. This timeless awareness provides another angle for understanding what existed before the Big Bang. Instead of a temporal before, we might be investigating the eternal present from which all apparent moments of time emerge. The Big Bang wouldn't be an event that happened in the past, but rather a perspective on the eternal creative process that generates the appearance of temporal sequence. From this timeless vantage point, asking what came before the Big Bang becomes like asking what comes before the present moment. The question assumes a temporal framework that doesn't apply to the fundamental creative process itself. All moments, including the Big Bang, emerge from the same eternal source of conscious creativity. This eternal consciousness hypothesis has begun attracting serious attention from physicists working on theories of quantum gravity. The mathematical frameworks they're developing to describe how space-time emerges from more fundamental processes bear striking resemblances to models of how conscious experience generates the appearance of objective reality. String theory's higher-dimensional mathematics might actually be describing the structure of consciousness itself. The extra dimensions that string theorists propose could represent different aspects or modes of awareness that project into our familiar three-dimensional experience. What we call particles and forces might be shadows cast by consciousness operating in these higher dimensional awareness spaces. Loop quantum gravity's discrete units of space and time might correspond to individual moments of conscious experience. The quantum loops that weave together to create the fabric of space-time could be expressions of consciousness examining itself from every possible angle, creating the appearance of spatial and temporal relationships through the process of self-observation. Even more speculatively, some theorists propose that the mathematical structures underlying all physical laws might actually be thoughts in a cosmic mind. The elegant equations that describe electromagnetic fields, gravitational waves, and quantum interactions could be expressions of how infinite consciousness organizes its self-understanding. From this perspective, doing physics becomes a form of telepathy with the cosmic mind. When scientists discover new laws of nature, they're not uncovering external truths about objective reality. They're accessing the thought patterns of the consciousness that generates all experience. Mathematics works so well to describe physical phenomena because mathematics is the language in which cosmic consciousness thinks. This cosmic mind hypothesis provides elegant solutions to some of the deepest puzzles in theoretical physics. The unreasonable effectiveness of mathematics in describing nature makes perfect sense if nature is mathematical thinking made manifest. The fine-tuning of physical constants becomes understandable if those constants represent the preferences and intentions of cosmic intelligence. The apparent randomness of quantum mechanics might actually be the signature of a mind so vast and creative that it can simultaneously explore every possible arrangement of reality. What seems random to our limited perspective might be perfectly coherent from the viewpoint of infinite consciousness. But this raises profound questions about the relationship between individual human consciousness and the cosmic awareness that might underlie all existence. Are we separate minds observing an external universe, or are we temporary focal points within a single, infinite field of consciousness that's exploring itself from countless perspectives simultaneously? Recent discoveries in neuroscience have begun challenging the assumption that consciousness is produced by brain activity. Studies of patients with extensive brain damage who maintain complex conscious experiences suggest that awareness might be more fundamental than neural processing. The brain might function more like a radio receiver that tunes into consciousness rather than a computer that generates it. Research into near-death experiences has documented cases where people report detailed, accurate perceptions during periods when brain activity was undetectable. These experiences suggest that consciousness might be able to operate independently of biological neural networks, accessing information through non-physical means. Studies of psychedelic states induced by substances like psilocybin and DMT have revealed that reducing brain activity often correlates with expanded awareness and access to information that seems to transcend individual memory. Knowledge. These states might provide glimpses of the cosmic consciousness that underlies individual identity. If consciousness is indeed fundamental rather than emergent, then the death of individual biological systems might not eliminate awareness, but rather return it to the cosmic field from which it temporarily emerged. Individual identity would be like a wave on the ocean of consciousness, real and meaningful during its existence, but ultimately inseparable from the infinite medium that gives it form. This understanding transforms our investigation into what came before the Big Bang into something far more personal and immediate. We're not just studying ancient cosmic history. We're exploring the fundamental nature of the awareness that's having this very experience right now. The same consciousness that might have initiated the Big Bang is the consciousness reading these words, thinking these thoughts, wondering about its own ultimate nature. The cosmic creative process isn't something that happened billions of years ago and then stopped. It's the ongoing activity of consciousness continuously generating the appearance of experience moment by moment. This realization suggests that understanding what came before the Big Bang requires developing deeper insight into the nature of present moment awareness itself. Every moment of conscious experience might be a fresh creation, emerging from the same source that generated the initial cosmic expansion. But here's where the investigation becomes both thrilling and terrifying. If consciousness really is fundamental, and if individual awareness can influence quantum processes and potentially access non-local information, then the quality of human consciousness might directly impact the future evolution of the universe itself. Our collective thoughts, intentions, and level of awareness might be programming the quantum field fluctuations that determine how reality unfolds. Humanity could be participating in a cosmic consciousness experiment where the outcome depends on how wisely and compassionately we develop our individual and collective awareness. The choices we make about technology, environment, social organization, and spiritual development might literally determine whether our region of space evolves toward greater harmony and complexity or degrades into chaos and simplification. We could be at a crucial decision point where consciousness either awakens to its cosmic creative potential or destroys itself before realizing what it actually is. This perspective makes every moment of conscious development cosmically significant. Learning to think more clearly, feel more compassionately, and perceive more accurately might be the most important work anyone can do, not just for personal growth, but for the evolution of existence itself. The investigation into what came before the Big Bang ultimately reveals that we might be asking about the eternal creative principle that's operating right now, generating this moment of experience and every moment that has ever existed or ever will exist. And that principle might be none other than the consciousness that's aware of reading these words, wondering about its own ultimate nature, and participating in the universe's ongoing journey of self-discovery through the mystery of individual experience within infinite awareness. The question transforms from historical inquiry to immediate exploration. What is the nature of the consciousness that makes any experience possible at all? And how can we develop that consciousness in ways that contribute to the cosmic evolution toward whatever lies beyond our current understanding of existence itself? We've journeyed to the very edge of existence itself, exploring 5 revolutionary hypotheses that challenge everything we thought we knew about the nature of reality. From eternal inflation creating infinite universes to cyclical cosmos bouncing through endless cycles of death and rebirth. From holographic projections encoding our 3-dimensional reality on distant 2-dimensional surfaces, to quantum many worlds splitting reality into infinite parallel branches with every measurement. From digital physics suggesting we might be living inside a cosmic computer program, to consciousness itself being the fundamental creative force that generates all experience. Each theory offers a radically different answer to what came before the Big Bang, yet they all point toward the same profound realization. Reality extends far beyond what we can observe or imagine. Consciousness might play a fundamental role in shaping the very fabric of existence. And our universe, however vast it might seem, represents just one small part of something infinitely larger and more mysterious. But here's what makes this investigation so urgent and transformative. These aren't just abstract mathematical concepts existing in the minds of theoretical physicists. They're insights that could fundamentally change how you understand your place in the cosmic story. If any of these theories are correct, then every moment of your conscious experience carries cosmic significance. Every choice you make might echo across infinite realities or influence the quantum processes that generate physical reality itself. The search for what came before the Big Bang ultimately reveals that we might be asking the wrong question entirely. Instead of seeking a temporal beginning, we've discovered that consciousness itself might be the eternal source from which all moments of time continuously emerge. You're not separate from this cosmic creative process. You are this process, temporarily focused through the lens of individual awareness, participating in the universe's ongoing journey of self-discovery. The biggest discovery of all might be that the same consciousness that initiated the Big Bang is the consciousness having this experience right now. The ultimate cosmic mystery and the ultimate personal mystery are the same question approached from different angles. What is the nature of the awareness that makes any experience possible at all? And that question will keep expanding our understanding of existence in ways we can't even begin to imagine.